So now disaster recovery overview. So our disaster recovery as a solutions architect professional or solution architect is a super important and exam aspects. You would like to like the disaster recovery and there's a white paper on it. You should read it, but I try to summarize everything clearly with graphs and diagrams in this lecture. So you don't have to read it if you don't want to. But overall, you can expect some questions on disaster recovery, and as a solution architect, you need to know about disaster recovery anyway. So don't worry, I try to make this as simple as possible for you. And so, what is a disaster first? Well, any event. It's any event that has a negative impact on a company's business continuity or finances. And so, disaster recovery is about preparing and recovering from these disasters. So what kind of disaster recovery can we do on AWS or on general? Well, we can do on premise to on premise. That means we have a first data center maybe in California, another data center maybe in Seattle, and so this is traditional disaster recovery. Okay, and it's actually very expensive. Or we can start using the cloud and do on premise as a main data center, and even if we have any disaster, use the cloud. So this is called a hybrid recovery approaches. Or if you are just all in the cloud, then you can do AWS cloud region A, cloud region A to cloud region B, and that would be a full cloud type of disaster recovery approaches. Now before we do the disaster recovery, we need to define two key terms, and you need to understand them from the exam perspective. The first one is called the RPO, recovery point objective, RPO, recovery point objective, and the second one is called the RTO, recovery time objective. So remember these terms, and I'm going to explain them right now. So what is RPO and RTO? So the first one is the RPO, recovery point objective. Okay, and so this is basically how often basically you run backups, how back in time you to recover, and when a disaster strikes, basically the time between the recovery point objective RPO and the disaster is going to be a data loss. Okay, and for example, if you back up data every hour and the disaster strikes, then you can go back in time for an hour, so you will have lost 1 hour of data. So the recovery point objective RPO, sometimes it can be an hour, sometimes it can be maybe 1 minute. It really depends on our requirements. So the RPO, sometimes it can be an hour, sometimes it can be maybe 1 minute. It really depends on our requirements. But RPO is how much of a data loss are you willing to accept in case of a disaster happens. RTO on the other side end is RTO on the other end is when you recover from your disaster. Okay, and so between the disaster and the RTO is the amount of downtime your application has. Sometimes it's okay to have like the 24 hours of downtime, but I don't think so. It is sometimes it's not okay, and maybe you just need 1 minute of downtime. Okay, so basically optimizing for the RPO and the RTO does drive some solution architecture decisions, and obviously here the smaller you want these things to be, usually the higher the cost you're gonna have to pay. So let's talk about other about disaster recovery strategies. The first one is backup and restore. So second one is Pilotlight, and the third one is warm standby, and the fourth one is hot site or multi-site approach. So if we basically rank them, all will have different RTO, recovery time objective. Backup and restore will have the smaller recovery time objective. Pilotlight and the warm standby and the multi-site, all these things cost more money, but they get a faster recovery time objective. That means you have a less downtime overall. So let's look at all of these options, all of these one by one in the details. So to really understand from an architectural standpoint what they mean, so backup and restore has high RPO, recovery point objective. That means that you have a corporate data center, for example, and here is your AWS cloud, and you have an S3 bucket. And so if you want to back up your data over time, maybe we can use AWS storage gateway and have some lifecycle policy to put data into Glacier for cost optimization purposes, or maybe once a week you are sending a ton of data into Glacier and Glacier using AWS Snowball. So here, if you use a Snowball, your RPO, recovery point objective, is going to be about 1 week, because if your data center burns or whatever and you lose all your data, then you have lost 1 week of data, because you send the Snowball device once a week if you are using the AWS cloud. Instead, maybe EPS volumes, Redshift and RDS, if you schedule regular snapshot and you back them up, then your RPO, recovery point objective, is going to be maybe 24 hours or 1 hour, based on how frequently you do create these snapshot. And then when you have disaster strike, you need to basically restore all your data. Then you can use AMIs to recreate EC2 instances and spin up your applications, or you can restore a stat from a snapshot and recreate your Amazon RDS database or your EBS volume or your Redshift, so whatever you want. So that can take a lot of time, as well as to restore this data, so you get a high recovery time objective as well. But the reason we do this is actually it's quite cheap to backup and restore. We don't manage infrastructure in the middle. We just recreate infrastructure when we need it and when we have a disaster. And so the only cost we have is the cost of storing these backups. So it gives you an idea to backup and restore very easy, pretty expensive, and not too expensive. And you get high recovery point objective and high recovery time objective. The second one is going to be Pilotlight. So here with the Pilotlight, a small version of the app is always running in the cloud, and so usually that's going to be your critical core, and this is what is called the Pilotlight. So it's very similar to backup and restore, but this time it's faster because your critical systems, they are already up and running, and so when you do recover, you just need to add on all the other systems that are not as critical. So let's have an example. So this is your data center. It has server and a database, and this is in the AWS cloud. This is the AWS cloud. Maybe you are going to do like continuous data replication from your critical database into RDS, which is going to be running at any time. So you get an RDS database already to go up and running. But your EC2 instances, they are not critical just yet. What's really important is your data, and so they are not running right now. But in case you have a disaster happening, Route 53 will allow you fail over from your server on your data center, recreate the EC2 instance in the cloud and make it up and running. But your RDS database is already ready. So here, what do we get is that we get a lower recovery point objective, and we get a lower recovery time objective, and we still manage cost. We still have to have RDS running, but just the RDS database is running. The rest is not, and your EC2 instances only are brought up, are created when you do a disaster recovery. So Pilotlight is very popular choice. Remember, it's only for the critical core assistance. Then we have warm standby. So warm standby is when you have full system up and running, but at a minimum size, so it's ready to go. But upon disaster, we can scale it to production load. So let's have a look here. We have a corporate data center. Maybe it's a bit more complicated this time. So we have a reverse proxy and an app server, and we have a master database. And currently our Route 53 is pointing the DNS to our corporate data center. And in the cloud, we'll still have our data replication to an RDS slave database that is running, and maybe we'll have an EC2 auto scaling group, but running at the minimum capacity. That's currently talking to our corporate data center database, and maybe we'll have an elastic load balancer as well, ready to go. And so if a disaster strikes, because we have a warm standby, we can use Route 53 to fail over to the elastic load balancer, and we can use the fail over to also change where the application is getting our data from. Maybe it's getting our data from the RDS slave now, and so we have effectively basically stood by, and then maybe using auto scaling, our application will scale pretty quickly. So this is a more costly thing to do now, because we already have an elastic load balancer and EC2 auto scaling running at any time. But again, you can decrease your recovery point objective and your recovery time objective doing that. So, and then finally we get the multi-site or hot site approach. It's very low RTO, recovery time objective, and we are talking minutes or seconds, but it's also very expensive. But you get two full production scales running on AWS and on-premise. So that means we have our on-premise data center, full production scale. You have your AWS data center, full production scale with some data replication happening. And so here what happens is that because you have a hot site that's already running, your Route 53 can route requests to both your corporate data center and the AWS cloud, and it's called an active type of setup. And so the idea here is that the failover can happen. Your EC2 can fail over to your RDS slave database if need, but you get full production scales running on AWS and on premise. And so this costs a lot of money, but at the same time you are ready to fail over. You are ready, and you are running into uh, multi type of the infrastructure, which is quite cool. Multi DC type of infrastructure, which is quite cool. Okay. Finally, if you wanted to go all cloud, it would be the same kind of architecture. It will be a multi-region. So maybe we could use Aurora here, because we are really in the cloud. So we have a master database in a region, and then we have your Aurora global database that's been replicated to another region as a slave. And so these both regions are working for me. And when I want to fail over, I will be ready to go full production scale again in another region if I need to. So this gives you an idea of all the strategies you can have for disaster recovery. It's really up to you to select the disaster recovery strategy you need. But the exam will ask you like basically based on some scenarios, what do you recommend? Do you recommend backup and restore, Pilotlight? Do you recommend multi-site, or do you recommend hot site? So all this kind of the stuff. So the warm backups and all that stuff. Okay, so finally disaster recovery tips, and it's more like real life stuff. So for backups, you can use EBS snapshots, RDS automated snapshots and backups, etc. And you can push all these snapshots regularly to S3IA in frequently access and Glacier. You can implement a life cycle policy. You can use cross-region replication if you wanted to make sure these backups would be in different regions. And if you want to share your data from on-premise to the cloud, a snowball or a storage gateway. A storage gateway would be the great technology for high availability. Using Route 53 to migrate DNS from a region to another region is really helpful and easy to implement. We can also use technology to have multi-AZ implemented, such as RDS multi-AZ, Elastic multi-AZ, EFS, S3. All these things running are highly available by default if you enable that website. And if you're talking about the high availability of your network, maybe you have implemented direct connect to connect from your corporate data center to AWS. But what if the connection goes down for any reason? Maybe you can use site-to-site VPN as a recovery option for your network. So in terms of replication, you can use RDS replication cross-region, Aurora and global databases. Maybe you can use database replication software to do your on-premise database to RDS, or maybe you can use a storage gateway as well. So in terms of automation, so how do we recover from the disasters in such a case? I think you would know already here that the CloudFormation or Elastic Beanstalk can help recreate whole new environments in the cloud very quickly. Or maybe if you use CloudWatch, we can recover or reboot our EC2 instances when the CloudWatch alarm fails. So AWS Lambda can also be great to customize automation. So they are great to do REST API, but they can also be used to automate your entire AWS infrastructure. And so overall, if you can manage to automate your whole disaster recovery, then you are really well set for the success. And then finally, chaos testing. So how do we know how to recover from a disaster? then then you create a disaster. Then so an example that's I think widely quoted now in the AWS world is that the Netflix, they run everything on the AWS, and they have created something called Simian army, and they randomly terminate EC2 instances. For example, they do so much more, but basically they just take an application server and terminate it randomly in production. Okay, not in a divert test, in production. So they want to make sure that their infrastructure is capable to survive failures, and so that's why they are running a bunch of chaos monkeys that just terminate stuff randomly, just to make sure that their infrastructure is rock solid and can survive any type of failures. So that's it for this section on disaster recovery, and I hope you enjoyed it, and I will see you in the next lecture.